All right, hey class. Today we're going to be learning about domain and range of graphs, and this is particularly a tough topic to sort of cover, just because it requires you to sort of think outside the box and think about what the bounds of these functions are. So let's take a look at the domain and range of a couple examples here. So the domain and range of this first graph. Now this is what kind of function? It's a linear function, so it's a line. It extends on forever in both directions. And I'm going to try and break this down as easy as I can. So domain, again, are the x values. Okay, so our x values, again, extend right and left. Okay, so we're looking for the bounds of the highest and the lowest x value that it could possibly reach. So in this problem, do I have a bound to how far right and how far left my values go? Okay. In this function, no, I don't, because this heads off to the right forever, heads off to the left forever. So this is just going to be all real numbers. Okay, so all real numbers, just because we have x and y going off in both directions forever. If we want to do it in a set notation, we would have open bracket, and then we would have negative infinity to infinity, because it extends in both directions forever. So now let's talk about range. Range is the y values. Okay, and that is up and down, how far up and how far down this graph can actually reach. So if you look here, again, it extends up forever, it extends down forever. So this is going to be all real numbers once again. And again, we can write it in this set of negative infinity to infinity. That's the range values. It extends forever in both directions. Okay, so 2. We have our parabola here. A parabola is a quadratic function just graphed on the coordinate plane. And we already, or in the next video, I'm going to talk about how to find minimums and maximums of these parabolas and of just graphs in general. But in this case, we'll talk about minimums because that's what we have here. Our y value has a minimum value of 0, right? So we can only go up from that point. So I'm going to start off with our range. So we're going to have all real numbers such that, so all real numbers such that y is greater than or equal to 0. Okay, so it has to be greater than that value. It could be equal to 0, but the minimum value that it could be is 0. Okay, what about x values? If we look at this graph, it looks like it's going to become a U, but parabolas actually are those special cases where it does extend off in infinity in both directions. So in the right and the left, it extends forever, so it's just all real numbers, and we know that it's negative infinity to infinity. It does not have any bounds. Okay, so this last one's a little tricky, but go ahead and pause the video, try and figure out this one on your own. So you can do it. I believe in you. And I'm just going to sit here and stare at you creepily. Are you figuring it out? Can you do it? Cue heavy breathing. All right. Eyes are starting to water. Okay, so let me give you the answer to this problem. Okay, so let's check out these solutions here. We have the domain, which is all real numbers such that x is less than -1 and x is greater than 2. So we have this one going off to the left forever. We have this point going off to the right forever. But just make sure that you take notice of our inequality symbols here, because we have a filled-in circle here and an open circle there. We need to make sure that they reflect that. The range, the highest point that we can go is this line right here. So at 1, 2, 3, 4, y equals 4. Everything below that is true because this line extends down forever. Okay, so let's talk about one more thing, which is actually evaluating functions, which we're going to get to in a later video, but it's on this page, so why not, right? Right. Okay, so find the range. All this is we plug a number in for x to find the y. So our two functions here, we have y equals 1/2 x minus 7, or f of x equals 1/2 x minus 7. I'll be talking about this. This is the way that we write in function notation. F of x, a function of x. Okay, so we can see the input and output at the same time. All right, so to find our range, we need to first have a domain, right? So to find the range, all we're going to do is plug these numbers back in. So I'm going to do one by hand, and then I'm just going to sort of talk my way through the rest of them. A lot of these you could do in your head. So if I take this 2 and plug it in, so f of 2 equals 1/2 times 2 minus 7. I'm just plugging in our first value right there to get the first value in my ordered pair, or in my set. So I have 1/2 times 2, that's 1. 1 minus 7 is -6, so my first value is -6. Okay, I'm going to put a comma. Let's do the next value. So f of 4, okay, equals, half of 4 is 2. 2 minus 7 is what? Right, -5. Good. So I get -5. I'm going to tell you that it's just going to follow that pattern: -4, -3, -2. Okay. So you can sort of figure out the pattern as you go and just finish out the range. So pause the video, just plug these numbers in and chug. Just make sure that here I'm going to set up your first one for you so you don't get confused. F of -3, make sure that you use parentheses, because a negative times a negative, when we square it, is going to become a positive. And if you don't use those parentheses, if you use a calculator, it's going to give you the wrong answer. Okay, so go ahead and pause the video, and we'll resume in about 10 seconds. Remember, you can do it. I believe in you. Go fight, win. And some more cliches. Okay, so go ahead and check your answer. We have the range here. I just started finding this out, and I did actually notice that this one is a parabola, right? Anytime you square or have a square within your function, it's going to be a quadratic. So we have these values here that are going to start repeating because it looks like a u. So we're going to have repeating y values that are on the same line. So we had -4, -7, -8, and then -7, -4, -1, 8. All right, so hopefully this has been helpful, and I will see you in the next video. Peace.